So we have this block X moving along with a certain speed. There's block Y, which looks like it's at rest. So there's going to be some kind of collision between the two. What you might expect is that since this one has such a larger mass, it's going to run into this one, and the two are going to move off together. That's what seems reasonable. For them not to move off together would mean that the block X would have to end up going backward, which doesn't seem to make sense. But let's read the question. So yes, it's initially at rest. Y collides. Final velocities after the collision. If the collision is elastic, so that means the kinetic energy remains the same. Now we lose kinetic energy when they stick together. Is inelastic. So if it's elastic, they can't stick together, which is what we predicted or expected what would happen. So this one is out. This one is B is not sticking together, C is not sticking together, and D is not sticking together. So we've eliminated one at this point. So now it comes down to actually doing a calculation. So we have P0 equals P, and we have MV, and then we have M2V2 plus, we should call that MX, MXVX plus MYVY. And so this was 2 times 4, and MX is 2, and we don't know VX, and MY is 0.5 times VY. So somehow, 2VX plus 0.5 VY must add up to 8. So we could test those. 2 times 1.8 plus 0.5 times 5.6. Does it equal 8? So this is 3.6, and half of 5.6 is 2.8. So that does not equal 8, so it looks like choice B is out. Let's try the next one. 2Vx plus 0.5 Vy. 2 times 2.4 plus 0.5 times 6.4 is 4.8. Plus 3.2 is 8. So it looks like that's possible. Because remember, we know the momentum is conserved, but it tells us the kinetic energy must also be conserved. We won't test the kinetic energy. Maybe we can eliminate this last one. And then the last one, 2Vx plus 0.5 Vy. Vx, 2 times minus 0.8 plus 0.5 times 19.2. So this is minus 1.6, and this is half of 9.2 is 9.6, so that is 8. So you can see the momentum is conserved in both of these instances. The question is the kinetic energy conserved? Does the kinetic energy remain the same? So let's check that out. Our initial kinetic energy is 1/2 mv squared, and the mass we are told is 2. And the velocity was 4. So the total kinetic energy must be 16 joules. We're looking for 16 joules to be preserved. So let's try choice C. We have 1/2 mv squared plus 1/2 mv squared. 1/2 the mass of 2 and the speed of 2.4 plus 1/2 of 1/2 times its speed, which is 6.4 squared. So we're left with 2.4 squared plus 1/4 of 6.4 squared. And doing out the calculations using our calculator, is indeed 16. So it looks like C is our answer. And if we're due to the calculation for the other one, just to be sure, we have 1/2 of 2 times 0.8 squared plus 1/2 of 1/2 times 19.2 squared. Gives us 92.8 joules. So choice C, and this is 92.8 joules. Choice D is out.